Let's do 4.4. 23 is one of the questions that was asked, and so 23 says solve the inequality algebraically. 2x to the third greater than negative 8x squared. So this becomes 2x to the third, add 8x squared to both sides. So what's this look like? Well, it's a cubic. It's a positive cubic, so it's got to go something like that, or maybe just like that, a little flatter in here. So let's factor this. Well, an x squared comes out, and we'd have, actually a 2x squared comes out, and we'd have x plus 4. So it bounces at 0 and it crosses at negative 4. And so when is this graph, this y value, greater than 0? Well, it's greater than 0 from here to there. It's not greater at 0, but then it's greater beyond. So it's from negative 4 to 0. It's great. The y values are greater than 0, and then from 0 to infinity. Pretty simple if you can just think about the graph. Okay, next one is 33. And 33 says solve this one. X plus 1 over x minus 1 greater than 0. Well, this, knowing what we know now, this has a vertical asymptote at 1. A horizontal asymptote of, since it's same degree, ratio of the coefficients, horizontal asymptote of 1. And when, let's see, y-intercept, put 0 in, we get minus 1. Minus 1 for the y-intercept. And x-intercept, how do we make a fraction be 0? That would be at minus 1. So this curve must go in here, and it goes opposite because that's a single factor, so it must be up here. And the question is, when is this fraction greater than 0? When are these y values greater than 0? Well, all these y values are positive, greater than 0, so that would be from negative infinity, from x negative infinity up to negative 1. This has a positive y value, and it has a positive y value from 1 to infinity. Okay, the next one is 39. Is it 39? Let me check here. 39. And it says solve x plus 4 divided by x minus 2 less than or equal to 1. So let's subtract 1 and we get x plus 4 over x minus 2 minus 1 less than or equal to 0. And now let's take and get a common denominator. So we have x plus 4 over x minus 2 minus x minus 2 over x minus 2. That's 1. Common denominator, so we have x minus 2 in the denominator. In the numerator, we've got x minus x, which is 0. 4 minus a minus 2, that'd be 6. So this has a vertical asymptote at 2. A horizontal, the degree of the numerator is less than the denominator, so horizontal asymptote of 0. And this has no x-intercepts because you can't get the numerator equal to 0. And it has if you put in 0 for x, you get negative 3. 6 over negative 2 is negative 3. It gets closer to here, so it must go this way. Since it's a single factor, it must be opposite up here. And so we've got something that looks like this, and we're supposed to find out when the y values are less than 0. All of these are less than 0. Those are not. And so we would say from negative infinity to 2. That's 39, and now 44. 44 is 5 over x minus 3 greater than 3 over x plus 1. So let's get it 0 on one side, so we get 5 over x minus 3 minus 3 over x plus 1 greater than 0. Let's get a common denominator, and since there's no way to make this one be that or that but that, by multiplying we have to multiply by x plus 1, x plus 1, x minus 3, x minus 3. So now the common denominator is x plus 1 and x minus 3, and the numerator is 5x plus 5 minus 3x. Minus 3 times the minus 3 is plus 9. So that simplifies to 5x minus 3x is 2x. 5 plus 9 is plus 14 over x plus 1, x minus 3. So this is 2 times x plus 7. So what do we know? Well, the degree of the numerator is less than the denominator, therefore it's a horizontal asymptote at 0, vertical asymptote at minus 1, and at plus 3. And and it has a, if we put 0 in for x to find the y-intercept, that would be 2 times, it's 14, 2 times 0 plus 14 is 14 over 1 times negative 3, 14 divided by negative 3, 14 thirds negative, 3, 6, 9, 12, 15, 14 thirds. So it goes through there, crosses the x-axis, y would be 0 when x is negative 7. So it crosses at negative 7, it crosses here, it gets closer and closer to this out here and out there. So we're going to be concerned about points below here, what side it's on. Is it on the bottom side or the top side? This place, and out here. So we want to check between negative infinity to negative 7. We want to check from negative 7 to negative 1. We want to check from negative 1 to 3, and from 3 to infinity. Some of these will be greater than 0 and some will not. In fact, we've already checked between negative 1 and 3. We found out it was, the y-intercept was negative, and that's not greater than 0, so we don't want that section. How about something out here? Well, negative negative 2's in this interval. If I put negative 2, I could actually check in the original one. Negative 2, that'd be 5 over negative 5. That's negative 1. And 3 over negative 2 plus 1 is negative 2 plus 1 is negative 1. That'd be negative 3. And is negative 1 greater than negative 3? And it is. So it must be up here someplace, and I could check other places. It's and I could go back to here and I could put in the negative 2. This would be positive. Negative 2, that would be negative, and this would be negative. So negative times negative is positive. So this is greater than 0 for negative 2. So it must be greater than there for all of this. So it must be up here. Then it must go negative and get closer out here. So probably not for negative 8. If I put in negative 8, that's negative, that's negative, that's negative. So 2 times a negative over negative and negative is negative. So it's not greater than 0. So this one's out. The only question is now, is this positive? And so if I put in 4, I could put in here or check it in here, but let's check it here. 4. This would be positive, this would be positive, this would be positive, everything's positive, so it's greater than 0, so we want that. So we went from negative 7 to negative 1, or from 3 to infinity. Okay?